today we're talking about time series. So hopefully this is a topic that's of interest to you and relevant to your work. I mean, obviously, there's a lot of places that in healthcare and healthcare applications where time series comes into play, and driverless has a lot to offer there. Let's just let me. So the first thing I want to do is just cover some core concepts in driverless with regard to time series. So, you know, if you've done time series work before, it's useful to know where some of the concepts you're familiar with fit in when it comes to time series and what, you know, and where they fit in driverless. And if you're new to time series, you know, this will be useful as well. But they're just in setting up experiments in driverless and time series. I mean, you could imagine there's just some added components, right? Because you've got this additional element of time. So let's talk about this. And then there's some variations and other things that happen as well. So let's talk about. We're going to be on Aquarium again. We're going to be in Lab 4. So, I mean, if you've been following along there, or if you want to come back to this later, the data that we're going to be using today are on Aquarium. Let's just begin by talking about time series, and some of this will be super basic, but let's just build upon the basics and get to more complex elements. So obviously, you all know what time series is, and one of the tricks in time series is that there are, not only do you have data over time, so you have correlated data, but there's oftentimes patterns with that data. So you want to account for the correlation. You know, namely, you know, can you want to make use of past information to make future predictions, right? Because the data are correlated, you're going to be able to do that. But you also want to be able to extract out these patterns that are oftentimes found in data, in time series data. All right, so another part of time series that you may have dealt with in the past is oftentimes when you get data, when you have time series data, it's not just a single time series, right? You could, it's often the case that you're dealing with time series data coming from multiple entities, you know, all of the same nature. So for example, you know, the flu data, we're going to look at modeling flu data from the CDC today. And, you know, you've got flu data from all 50 states, right? And you could just aggregate all that data and look at national counts, but it's often, you know, the case that you want to model each state separately, while at the same time making use of common patterns across states, right? So you don't want to just run 50 separate analyses. You want to run a single analysis, but incorporate this group component. So that'll be something we talk about when we get into driverless, is incorporating multiple groups. You know, and whether, you know, we'll be talking about states today, but, you know, if you're in retail, you know, you're talking about stores. If you're in hospitals, you're talking about, you know, clinics, or, you know, or departments, you know, within the hospital, academic departments. So yeah, like, groups just show up a lot when we're talking about time series. When it comes to in driverless, there are other couple key components here that we need to be aware of when we're setting up an experiment. And, you know, again, I'm not sure how you've dealt with this in the past. That's kind of the structure of the data, but I want to talk about a couple of different elements here. So obviously, you know, we're talking about using historical data to make future predictions. So the historical data here is the green, and the future, you know, length of time where we're making predictions for is in, oh, did I say green? The historical data is blue, and the area where we're making predictions is green. Okay, so and that's straightforward enough. But then there's also some other elements here. One is it's often the case that you have a gap, right? You have a gap between the time where you have historical data and when you want to make predictions. So let's say I want to start making predictions for tomorrow. Well, I likely, in a lot of cases, I don't have my latest up-to-date data through today. Maybe my latest up-to-date data goes through last week, right? And so I might have a week time period where I don't have any data. So I've got a gap there. And so in driverless, we want to account for that. It could be longer, but oftentimes in time series data, you've got this gap between your historical data and when you want to, and the time period where you want to start making predictions. This is so one of the ways in which driverless accounts for this or incorporates this gap is it takes the structure of the data that you specify. So you've got your training data, you've got this gap, and then you've got a forecast horizon. And you're going to specify that when you set up the experiment. You're going to hand it the training data. It's going to see how long that training data spans. You're going to specify, what kind of gap there is, and then you're going to tell it how long your forecast horizon is, how long you want to, do this. So what driverless will then do in building out the experiment, it'll replicate that same structure backwards. So, similar in other experiments that we've talked about or other data settings, driverless is not going to use the test set, in this case, the forecast horizon, to build the experiment. Well, what it'll instead do, but we still want to make, we still want to make use of that structure of the data. So what driverless will do will work backwards within the training data set. So it'll replicate that structure of the gap and the forecast horizon backwards through the training data set, and use that to validate the predictions that are being made. Okay. And before I move on, I'll talk a little bit more in detail about how that might happen. But any questions on the overall structure of the data, what driverless is expecting in terms of the training data, in terms of the test data, or the area where you want to make forecasts, or the gap, or any questions on that? I'm just keeping an eye on the chat here or the Q&A. Nothing so far. Okay. So let's talk about how driverless might do that, how it might replicate the structure of this gap and of the forecast horizon back to the data. There's a couple ways in which this could happen. So one way is just a single time split, where the most recent training data set becomes, the most recent training data becomes your validation data set. So by validation, again, I'm talking about this gap, this structure that's been replicated within the training data, right? This is your validation scheme. So it's the yellow along with the preceding gap there in the lower part of the graph.
David?
Yes.
I see we have a question perhaps you can address in this point, just came in. A little more clarification on the gap. The question is, can you please explain a real case with what the gap is?
Yeah, so the gap is, let me go back here. The example I gave was, let's say, let's stick with the flu data example, because that's the data we'll be using today. Let's say I want to start making predictions as to what flu counts will be in a given state tomorrow, right? I want to know what tomorrow's count will be. And I have historical data going back maybe several years. What I don't have is data, through today, right? I mean, the CDC is still collecting this data, in real time, but it's not like they have this magical process where they are able to establish how many people, how many US citizens have the flu today, right? It takes some time for them to gather that data, right? So I might have the complete CDC data through maybe last month. Okay, maybe, and I'm not sure, I have to look at how often they release the data. But let's say I have it through the end of May. Okay, I have accurate data through the end of May, and I want to start making predictions for tomorrow. Then I've got a gap in there. There's a gap in my data, right? A gap of about 3 weeks, between the time that my last data, have come in, and when I want to start making predictions. Does that make sense?
I see the person who asked said that she got it or he got it. Okay. Thanks.
Okay, great. Okay. And like I said, what we're going to do here is we're going to, that gap is important, right? It's a structure of our data. And so, in validating a model, we're going to replicate that structure backwards through the training data set. So not only are we going to replicate the forecast horizon back through the training data set, but we're also going to replicate that gap just so we can model as accurately as possible. Right? I mean, because if you think about this, looking at the lower part of this chart right here, okay? Ignore the orange, or ignore the last gap in the test set out here, right? That's got, we're not going to use that to build our model. Instead, we're going to use what's within the entire green section here on the top. So if you look at the lower part of the graph here, what we're going to do here is use a subset of the training data to make those predictions for the yellow area. But in making those predictions, we know that there's a gap. So in real life, we're going to have that gap. So we want to replicate that same gap in our in when we're validating our model to most accurately mirror real life conditions and real prediction conditions. So we're going to see how good of predictions we can make with that gap in there, right? That gap could hinder our ability to make really super accurate predictions, but we want to replicate that because that's what we're going to be facing in real life. Okay, we know that there's going to be a gap there, and so let's for our validation process, let's see how let's build a model, knowing that gap is there. Let's build a model to build the best possible model that will that will make predictions for our forecast horizon with the yellow piece here. Okay. All right. So there are a couple of different ways we could do this. The way we just described is we're just going to take our training data and use the last chunk of our training data as the validation data. But there are a couple other ways in which we could do this as well. Right, you could have a rolling window with adjusting training size. So this is a multi-window validation scheme, where we're successfully, working backwards here, using different validation, schemas, or maybe more accurately, using different training data sets to build out models. Right, in a successive manner. Another way you could do it is rolling window with constant training size. So there are a couple different ways in which to actually implement this sort of process here. Right, there are a couple different validation schemas. And what driverless is going to do is, and you can fine tune this. You could go into driverless and specify which one you want to use. But a lot of this comes down to the data that you're using, and then the dial settings in a time series experiment. Driverless is just going to pick the validation schema that's going to work best for your scenario. All right. So that's one of the more complicated pieces of time series analysis in driverless, but hopefully you see the reason for that. Hopefully you see why why we're doing this, right? We're in need of a validation schema, and this is the way we're going to do this. If you're new to time series, another way to think about this is, in typical experiments, you're using cross-validation, right? Within the training data to build out a model. Well, we're not going to randomly, pull out pieces of our training data set to build out a model here, because there is this time component, right? There's this temporal component, and we want to maintain that, as we're validating our model, regardless of where we are in the validation scheme. We want to be using past data to predict future events, and so that's why this is this differs from just straightforward cross-validation. There's something. Let me check the chat here. What happens if you have missing data in the training set? Data missing for specific days? That's a great question. So I'm not sure if you can see my chat here, or if you're looking at the chat. The question is, what happens if you have missing data in the training set? Data missing for specific days. Driverless will recognize that, and it'll replicate that while it's doing the validation schema. So that's a great question. Something that often occurs if you have missing data for specific days, and driverless is going to replicate that same pattern of missingness as it validates, as it builds out and validates a model. All right, let's move on to feature engineering. So feature engineering with time series is, it's kind of akin to feature engineering in NLP, right? So when we talk about feature engineering, with typical classification or regression sorts of problems, it's almost like a nice feature, but maybe optional. It can come across like that. Well, I'm going to try this transformation on this variable and see if it adds to the predictive power of my model. You saw in NLP that feature engineering really is a core component of being able to build out a model, right? You're given this string of text, and you've got to break that apart somehow. And there are multiple ways of breaking that apart. And then what do you do with those pieces that you've broken apart? And there's various ways of breaking that apart. And then there's various methods for dealing with the results of that. And all that falls under the category of feature engineering. And essentially it's essential. In time series, it's kind of akin to that, right? Making use of this temporal element of the data is really essential for putting together a good time series experiment. So let's talk about what feature engineering means when we talk about time series. So one is just decomposing the date, right? So this is common in time series. You're going to take the date field and break that apart into day, month, year, day of the week, week number of the year, whether it's a holiday or not. These are all things that driverless does automatically, as part of trying to identify elements that are predictive of future events. Another key component in time series data, we mentioned, you've got correlated data here. So can we use past variable values to predict future target values? So, you can, if you're pursuing a time series, this is not, new information at all, but essentially, driverless is creating lags for you. When you feed it the target variable, driverless is going to break that down. And so lag 1 here is just the target value shifted downwards. So, lag 1, essentially, you're looking at whether past values of the target are predictive of future values. So if you were, a simple example. Well, let's stick with the flu example again. Knowing today's flu count, does that contain information about tomorrow's flu count? Well, yeah. This is not a random walk we're talking about here. It's very correlated. And knowing today's value or last week's value is highly informative of knowing, next week's value. So driverless is creating these lags for you behind the scenes, both for the target itself and for additional variables. So driverless will lag the target itself, but it's also going to lag values of other variables in your data set to see if those are also predictive of the target. Another common component in time series in general is just the concept of windows, and making use of kind of a window of time, so to speak. So here, we're looking at this last column out here is a moving average of 3 time periods. There's a weighted moving average that you can calculate. And you're weighting it based on how far in the past the event was. So, and then there's also an exponential smoothing. And again, it's essentially taking a window and weighting, more recent events, giving more recent events a heavier weight than events that have happened further back in time. And then you can also do other things with those windows. Take the standard deviation of them, look at the max, look at the skew. Again, these are all things driverless is doing as part of when we talk about feature engineering. You can also look at interactions, right? Interactions between variables, between lags. So the difference between lag 1 and lag 2, difference between lag 1 and lag 3, and so on. Again, if you're doing a time series analysis manually, these are all things you'd likely try, or maybe there's a handful of these you've tried in the past, and it's not always the case that each one of these is predictive, but they can be. It's just like any other engineered feature. It's possible that in this particular scenario, this particular engineered feature is predictive of future values. Another common element in time series is the concept of trends. So, driverless, has several measures of trend, and it incorporates that in as an engineered feature. And so then we can also look at transformations of the target itself, the square root of the target, the log of the target, the difference between the target and its most recent value. So these are what's referred to as target transformations. All right. If you've done enough time series, you also know that there are different ways of calculating lags, right? So you could have daily lags, you could have weekly lags, one might be more predictive in a certain environment than another, right? For some data scenarios you're dealing with, daily lags might be the most appropriate. However, in other scenarios, it might be weekly data that's more predictive. But driverless is evaluating different lag sizes while it's doing everything else, and assessing what's most appropriate for this particular experiment that you're running. How much do I want to spend on? One thing I'll just mention here in passing, I don't know that we need to spend a lot of time on it. I'm not sure how much you've dealt with this in the past, if you've done time series analysis, but it can be the case if you give a platform, if you give a modeling platform of a training data set and a test data set, and your forecast horizon is actually shorter than the length of your test set. What you could end up with is okay predictions for that first chunk of your test data, but then bad predictions for the rest of it. And driverless has a variety of methods in place to avoid that problem. And one of these is called test time augmentation, and another is just extending the training set data set and refitting. So if you have used these sorts of approaches in the past, driverless is on the fly determining which one is the best approach. If you're feeding driverless a test set that's much longer than your forecast horizon, driverless is determining the best approach for you. But in expert settings, you can go in and manually specify which one you'd like to use. So that's available in driverless. Like everything else, driverless is using a genetic algorithm to build out the model. And we can come back and spend more time on this if you want, but you may have covered this elsewhere. Just kind of an outline of where driverless is, or how driverless is searching the model space. Any questions? We're going to hop over to driverless. And actually, let me just check one thing here. I just want to kick off a couple of things here that I want to run and make sure that it's ready for us. So the data we're going to be dealing with today is just flu data from the CDC. I've also pulled together a couple other data sources just to augment this data. But that's the data we're dealing with. I don't know if any of you are involved in this sort of work, either with the flu or we're involved in work with modeling COVID. But that's the data we're going to be dealing with. So let's go. This is an aquarium, and we'll go to data sets, and let's just walk through this process here. We're dealing with, and I've logged into Aquarium with username and password health, and that gives me access to kind of a collection of data sets dealing with health-related outcomes. We're going to be looking at the flu time series data, and this is part of this comes from the CDC. Part of this comes from some other data sources that I've pulled from. So let's just take a look at the data. So so number one, we have a region type here. I don't know that that's going to be very informative. We'll take a look at the raw data. Actually, let's do that first. Let's take a look at the raw data before we look at kind of summaries. So the region type is not informative, right? They all have the same value, but we get separate values for each state. So if you look here, let's just take a look at several columns. So we have a state column. We have this unweighted ILI measure, and this is the CDC's measure of flu activity. Okay, so we have that by state, but then we also have a date field here. So the weeks, when the week started. So if you notice here, for a bunch of rows here, it's all the same date, and it's because it's sorted by date here. But for each date, we have a separate outcome variable for each state here. So this is not IID data, right? We've got this date element, but then we've also got this grouping variable of state. So ideally, what we'd like here is we'd like to do a time series on this to make use of past data and make future predictions. but we'd like to also, basically have separate predictions for each of the 50 states without actually having to run 50 separate time series analyses. Okay, and that's what we're going to do here. All of the same functionality, that we've gone over in the past for modifying, for setting up an experiment is available for time series. So, we could modify this data by recipe, either by uploading code or doing live code here on the fly to make adjustments to our data, whether that's data cleaning or whether it's data preprocessing or or whatever it is. I didn't mean to. And then we have, our summary. Our summary of each column here. We can just ensure that data read correctly. We do have a couple of columns here where everything's missing. It's because these were pulled from some demographic databases that, for some of the age categories, it just didn't have data. But we could go through and clean that up. Driverless will exclude those columns anyway, but it pulled in additional data from that was of interest to us. So we've got some data there for helping us predict the flu. We can do automatic visualization on this data. Okay, and we don't have to do a deep dive on this. You've seen this before, but this is available for time series data as well. We've already split the data here into training and test. So let's just go through and talk about how to set up a time series experiment in driverless. So let's go to the predict. And we'll call it, I might have a completed experiment called flu baseline. So I'll just call it, I'll just add something else to the name here. We have our test data set. Oh, actually, before I do this, let me point out one thing. Let me go back to data sets. When you're splitting this in the test and train, right? With a typical experiment, where it's a classification or regression problem, the data are just split randomly. But one key component when you're splitting a data set for time series into test and train, and we could call this flu train and flu test. We've got a target column, which is unweighted ILI. And then we have a time column. And this is important to specify when you've got a time series experiment, because, again, you don't just want random columns or random rows to be taken out, to create a test or training data set, right? You want to respect that temporal component. You want your training data set to be the first part of your data in time, and you want your test data set to be the second part. So it is important when you're doing a split, and again, this is, whatever platform you're using, you'd want to do this, but here in driverless, this is how you would do it. You would specify the time column. Where's my week start? There it is. Week start is my time column. And this would ensure that that temporal component was respected, right, and preserved, that my training data would all occur before my test data. Okay. I see a couple of comments in the chat. Let me just check here. So the first question here is, are these time series feature engineering techniques available for longitudinal binary classification problems in driverless? Automatic calculating lags, moving averages can be really useful. I would agree with that. So when you're talking about longitudinal binary classification problems, I assume you've got a date field in there. But maybe I'm misunderstanding the nature of your data. Okay, so what you can do with that is so you could set up two separate experiments. So this would be something interesting to do, right? Is you could set up two separate experiments. One is just ignoring the date field or using the date field as just another variable altogether. But then setting up this data scenario you have as actually a time series experiment where you specify the date field, and then what you would do is you would observe whether some of these date related feature transformations turn out to be significant. So oftentimes what we'll do is we've got data by date. But it's possible that lags don't matter at all, right? It's possible that the data that I have could be treated as IID, just because there's no benefit to looking at historical values. If I'm dealing with like some sort of random walk, so what you can do is, what I would recommend is setting that up as a time series experiment, and then assessing, looking at feature importance, and seeing whether transformations such as the lag, such as some of these other elements actually show up as being significant. And if they do, stick with that approach. And if not, then just treating it as IID data. Does that make sense? And then, are there multivariate time series algorithms driverless? So there are. Let's wait until we get to recipes. But I will say, what driverless here is doing is multivariate time series. So, right, because of this grouping variable. So, we can take a look at the documentation and exactly, what, I mean, I don't know that it's using one of the algorithms that you mentioned here, the SREMA. But it's possible there could be algorithms, model recipes for those approaches that you incorporate. Like with anything else, if the model functionality isn't natively there in driverless, you can create recipes for that. But I mean, what we are doing here is multivariate time series. I would just have to look at the exact algorithms that are being used for that. Let me just check. Does the splitter account for groups automatically, or does it need to be specified? We're not specifying a group variable there. It's assuming that, and I don't think you really need to, right? The important thing is the date field. Now, I mean, you're going to run into problems if for certain dates you just don't have data for certain groups, right? I think what the assumption here is that if you're sorting if it's splitting it by date, for both those created data sets, you're going to have data, near complete data for both groups, or at least equal amount of data for your groups. And even if you don't have equal amounts, that's fine too. Again, it's going to make use of the data you have. You just want to avoid the scenario where it turns out that in your test data set you don't have any data for specific groups. And I think most people would avoid that, or most people would be aware ahead of time if certain groups were just missing for later dates, right? If and you're trying to make predictions for those later dates. that, that would be an odd scenario. But no, for the splitter, you do not need to account for groups. Let me just see here. So the response to the comment about the binary, the longitudinal binary, thinking more of aggregating the engineering time series based features to be put into a binary classification problem. So one thing I don't know whether, obviously with any feature transformation, you can always incorporate additional transformations through recipes, right? So that might be another avenue. If there are very specific, if you're not setting up as a time series problem, but would like to include specific feature transformations, recipes is always an option. I would just have to play around with this particular scenario and see, which feature transformations are available for your particular problem. Let's hold off on that for a moment until we get into building the experiment. Then we can talk about this a little bit more. All right. Let's go into building this experiment. Go to our training data set. We're dealing with unweighted ILI here. Our test data set is flu test. Obviously dropped columns, any columns that are non-informative or that we don't, don't want involved in any process of model building. In this case, we can drop region type. I'll tell you, driverless will drop this automatically anyway, but we can drop that here. We know that that's non-informative. And then, the key component here is specifying a time column, which is week start. Once I specify that time column, a new collection of options opens up here, and I need to pay attention to these because these get at the heart of a lot of things I was talking about previously about the structure of the data. So number one, time groups. Do I have any time groups in this, or am I just doing a single time series analysis? And I do have time groups here. And your week, your date variable will always be included as part of that. And you want to identify any additional group columns. Now you can have multiple group columns. So let's say you had you got both store and department within each store. So what driverless would then do is create, it would be doing multiple variant time series analysis, and you'd get separate predictions for each store and department, right? So you would do a search, or you evaluate results for each of those smaller entities, the combination of store and department. But we've just got the one group variable here, which is state. My forecast horizon here, I'm just going to put, even though, so the 20 here, driverless is taking a look at my test data and seeing how long it spans. So it's seeing it spans for 20 weeks here. But I'm just going to put 4 weeks. So this is where I'm feeding driverless a test set that's longer than my forecast horizon. So it's going to use one of those two methods like we described previously, such as test time augmentation, to ensure that predictions are good for the entire test data set. Driverless here is taking a look at my training and test. And it seemed that I actually don't have a gap between the two. And I don't in this case because I just downloaded all of the data from the CDC and then just split that data. So it's not, I'm not dealing with a scenario here where I actually do have a gap. If I was doing, if I was modeling real world conditions, I might want to deliberately impose some sort of gap. But I'm just going to leave that at 0 right now. But just keep in mind that is an important field if that's part of your data collection process. If you've got a gap in there. The last field I want to talk about here is unavailable columns at prediction time. This is actually a pretty important one. So it's like, oftentimes with time series analysis, and you're collecting data, there could be variables that you collect, over time, but whose value you wouldn't actually have at the time of prediction. So let me give you an example. If I was, let's stick with flu data. So in my flu data, if I had the flu count for that day, and I also had the average temperature for the state on that day, that would be a problem, right? In using that information to make future predictions, right? So if I'm using the most recent temp data. Right, because I don't have, let's say I'm trying to make a prediction for tomorrow. I don't have tomorrow's temperature yet, right? So if I'm building out a model where I'm pretending like I actually do have that data, then that's gonna be a problem. So if there was a column in my data that said that gave that information, that gave daily temp or daily average temp for the state, then I would specify here that that's unavailable at prediction time, that I'm not going to have that data. Same thing with something like if I'm doing something like if I'm modeling sales at a particular store, and in my data set I actually have traffic by day, how many people entered my store on that day. Well, if I'm predicting sales for tomorrow, I don't know yet how many people are going to be in my store tomorrow. So I would need to specify that as one of the columns that I'm not going to have at prediction time. And what driverless will do here, the reason why we just don't exclude it altogether with drop columns is what driverless is going to do then is it's going to use lagged features of that column instead of the actual, the most recent values. So it's it's actually something pretty useful here. And so I just need to be aware of that. I need to take a look at my data and see if there's any information I would not have, when I'm trying to make my predictions. In other words, if I'm making predictions for tomorrow, are there any of my values that I actually wouldn't have for tomorrow yet? If we take a look at my data here, and I actually did this deliberately, I do have a temperature field here, but what I did is I just specified the season average temperature. So I'm going to assume that this is not going to change, that this is not, specific to a particular day, that I've got, just the season average temperature, going forward as well. I'm not doing daily temperature here, but I'm just looking at the season average temperature. So I'm going to assume that that's fine. That I can keep that in my analysis. Any questions on that? So, at this point, I could launch my experiment. I've got everything I need to. I've specified the basic settings here. Once I put in the time column, I got to specify time groups, unavailable columns at prediction time, my forecast horizon, my gap, any gap between test and training. Let's talk about, let me go into expert settings here. Let's talk about a couple things there. So there's a specific tab here for time series. If you've done time series analysis, a number of things you may have worked with some of these things. For example, we have customers who want custom validation splits for time series experiments. So you can manually enter in here splits for, and then it gives you information here. Provide very specific splits for validation. Recall that when we talked about, let me just go back to PowerPoint for a second here. So, driverless is identifying, what validation schema is best for your data, but you can manually control that, right? You can, and this is what this field is getting at here. If you want to do custom, validation splits, you can specify that. Again, you can look through these. You could specify which date and date time transformations are allowed. In terms of holidays, whether you're going to use holidays as part of one of your possible engineered features. You can specify countries here where they would come from. Most of these are self-explanatory. I'm just seeing if there's anything we want to explicitly address, or if you have any questions about any one of these, you can hop in the chat. Yeah, so enable holiday features, enable feature engineering from time column. I think I'll leave it there for now. Most of these are self-explanatory, especially if you've worked with time series data before. And likewise, recipes are always available as well. Let's take a look at a couple, time series related recipes. So if I go to, our H2O's GitHub, library of recipes. I could go into, I have to remind myself here. So under models and time series, yeah. So so here's an example of one. I don't know how many of you have used Facebook Profit. If you've worked in time series before, if you've used Facebook Profit, but that's an available recipe. Personally, and maybe this has been your experience as well. Facebook Profit has kind of taken off, or was widely adopted, at least for a while, mainly because it's so easy to use. But I think most people have found that the performance is not that great. But you can include it here as a recipe. If I were to select this, get the raw code, select that URL, then load custom recipe from URL. I actually don't know how long this will take to load, so maybe we'll skip this. But it's available there, and if we wanted to wait for that to load, it would then show up over here as one of our models. So works the same way as other approaches. Same thing with we could include. Let's go over to transformers. There's specific transformers for time series. Like AutoArima, is available as a transformer. So we could do that. Make sure it's available as part of some of our transformers. And I'll select it there, my auto ARIMA transformer. Hopefully that happens quickly. So any questions so far? And now, I mean, now we can just launch the experiment, and we can run several experiments. I keep on circling back to the question that was asked about the longitudinal binary classification problem. So what we might want to do there, Nikki, I don't know if you're on the call right now. I mean, for me, I would want to take a closer look at that data and think about how that might be structured, either as a time series or as a classification problem. I would just need to do a deeper dive on that one, and then see what recipes are available. I'll just click aboard here. Okay. There's a question. Oh, I might not be able to share the data. Yeah, if there's an example you could share, or simulated data, just to give us a sense of the data structure that you're dealing with. Sometimes it's helpful just to eyeball the structure, to have a concrete idea of the problem you're working on. That might be helpful. All right, well, I'll skip the rest of this now. You've seen this before. We just launched experiment. Let's go to some completed experiments. There are a couple of ones I ran here. One was just a flu baseline. Another one was with a couple of recipes. I used exponential smoothing and auto ARIMA, and it had slightly better performance on a but let's just go with flu baseline. So all of the things that you've grown accustomed to with driverless are available for time series experiments. Diagnosing the model on a new data set, scoring on another data set. One option with time series that's not available is transforming on another data set. Primarily because the transformations that are involved in time series experiments are very data set specific. We can download the predictions, so we can get the predictions for either our training or test data set. We can download the pipelines. We can take a look at the auto report. See exactly what went into this, and maybe compare the contents of this sort of an experiment to time series experiment. What you see, what you get in and so you can see here, where the contents of this will vary from a typical classification or regression experiment, because it is time series. So you get details here as to what exactly how what was used for the validation splits. We didn't specify any splits specifically, so the driverless decided these for us, and so on, right? So you get all the details of what went into this experiment. Let's take a quick look at MLI, and actually let me check one other thing. Hold on just a moment. All right, let's go to kind of visualizing some of the results here. So the MLI piece for time series obviously is going to look different than the MLI piece for classification or regression experiments. You know, we've got this sort of structure going on. We've got a you know, a training data set and then a forecast horizon. So, like I said, you know, we have, you know, it created separate predictions for each state. And it's going to give us a sense here of, you know, which states perform best versus which states did not perform well at all. There's a couple of things we do here. You know, we can download, you know, we can download all of our data. We can, you know, just in terms of, you know, visualizing, you know, we can search by state here. You know, so we can see, you know, we can pick any state that we want. But, you know, we can pick states that maybe, you know, performed really well, you know, and see visually, you know, how that looked. Let me expand this out. So, right, I can see here, here's my forecast horizon right here. And you know, for this particular state, you know, my forecast horizon actually was for a time period where it's predicted that there's not much flu activity. It's probably the summer, right? And in fact, here the end of my forecast horizon is basically the end of summer. So prediction will not a lot of activity there. Let's look at a state where it said, you know, I didn't do so well. And this is a little bit more informative, right? Because there's more activity going on, and I can see here that I under predicted what the actual was, and maybe part of the reason we can start talking about, like, well, why it under predicted. You know, it looked like this was this particular year was a year of unusually heavy activity, flu activity. So maybe it was to be expected that you know, I had you know, I underperformed. If I click on a specific date here, what I get for that date is I get Shapley values for that date. You know, what went in predictions for that date. So that could be useful as well, and I can download those. I will say starting in version, so this is version 190, and that's what you have at Aetna. Starting in version 192, which has been available for a little while now. There's actually quite a bit more available in MLI for time series. So if time series is something you do a lot, you know, I would check in on your upgrade schedule when you're due for an update, or maybe start that process. I don't know how, you know, how that works at Aetna, but I do want to make I do want to point out that there's quite a bit of additional tools now available on the MLI piece for time series. But it's potentially the case that what we have here is sufficient for your purposes, right? Because you can download all this information and you know, play with it in your own pipelines. So questions, any questions that I haven't addressed here? I think we've covered a lot of the basics of time series. It should at least, we've hopefully presented enough for you to get started on your own time series experiments. We do have a number of people on staff who are ranked very highly in the world, quite literally, calculus grandmasters who are among the top 5 in the world in time series. Actually, if I'm being honest, we have calculus grandmasters who are ranked, very highly in a lot of different fields, but time series is one of those. If you're running into issues, or if you have specific questions, we can help out with specific use cases that you're working on, or tricky complications that you're dealing with in your data. But hopefully we've presented here enough for you to start playing around with what's available in time series, maybe running some baseline models, seeing how the results compare against what maybe you've achieved using other platforms. While we're on the screen, actually, the one last thing here that I want to point out. So we can see all of the feature transformations that went into this analysis here. There's actually only one variable here that I can see that played a significant role that was unadjusted. Right, that was the original variable. The rest of these are all transformations, and a lot of them have to do with lags. So what I mentioned to the person who had the question about the longitudinal binary classification problem. If it were the case that lags were not, there were no lags here, no lagged variables. If lagged variables just were not significant predictors of future events, then that in and of itself would be informative, right? And you could potentially treat this as an IID experiment. All right. Any remaining questions?